this video by sharing the purpose of our visit to the Festival Idea Negeri Sembilan 2025. So on 29 October 2025 at the Dewan Tunku Chancellor USEM, our group went to the festival to observe the different innovations and understand how quality control and total quality management were applied in the real projects. So the real goal was to see how this tool help improve processes, solve problems, and also create better and more reliable solutions. So one of the innovations we focused on was Pakis One, which my group member will share more about next.
During our visit to the festival, our group selected Pakis, which is portable IoT integrated LiDAR system for real-time coastal turbidity monitoring. The project aims to detect contaminants such as turbidity in real time. The system integrates sensor, which is LiDAR, a microcontroller such as ESP32, and a dashboard to help users monitor water turbidity instantly. What caught our attention was how the innovation solved a real community problem, which is the difficulty of identifying polluted water sources quickly. We observed several design strengths in this project. First, the system delivers real-time sensing and alerts. Second, the dashboard displays data clearly. And the last one, the prototype is compact and portable, making it easy to bring anywhere.
In our observation, we found that the PAQIST system demonstrates several key applications of quality control and total quality tools within its design and validation process. Firstly, the field validation data reflect the principle of a control chart by collecting turbidity measurement from multiple coastal locations and comparing them with LiDAR signal strength. The researchers were able to monitor consistency, identify variation, and establish a reliable performance trend for the system. Secondly, the project directly applies the logic of cause and effect, or fishbone diagram, by considering various environmental factors that influence turbidity level. The differences in water, clarity, ecosystem condition, and the site characteristics explain why each location display distinct turbidity behavior. This systematic identification of factors support more accurate interpretation of the result. Lastly, the continuous IoT data transmission resembles the use of check sheets, where real-time information is recorded, verified, and stored for further analysis. They ensure that the data collection remains structured, dependable, and traceable.
Okay, in this project, two total quality tools were applied to support the development of the portable IoT integrated LiDAR system for real-time coastal turbidity monitoring. The first tool was the PDCA cycle. In the plan phase, the system requirements, calibration needs, and potential risks were identified. In the do phase, prototype assembly, sensor integration, and preliminary testing were carried out. The check phase involved evaluating turbidity data and detecting any inconsistencies. In the act phase, improvements were implemented, such as refining LiDAR alignment, stabilizing data transmission, and enhancing calibration accuracy. This cycle provided a structured method for continuous quality improvement.
The second tool of total quality was the cause and effect of fishbone diagram. This tool was used to categorize potential sources of measurement error under hardware, software, environment, method, and IoT connectivity. By identifying root causes clearly, more precise corrective actions could be taken. Overall, this total quality tool strengthened the innovation process by offering a systematic approach to problem solving, ensuring accuracy, and supporting consistent quality enhancement in the system development.
They can go hand in hand. Pakis One doesn't only measure turbidity, it integrates hardware, software, IoT, and cloud platforms. The innovation lies in making the system portable and scalable for environmental monitoring. This taught me that innovation is not just about creating something new, but ensuring it is consistent, reliable, and meets real-world standards. The clear correlation between LiDAR signal strength and turbidity proves that proper QC improves innovation outcome.
In this visit, our group learned how innovation and quality control must work together to create reliable system. Seeing PAQIST real-time turbidity validation helped us understand how tools like control charge and cause and effect analysis support accurate data. For me, personally, this experience improved how I interpret field result and show me the importance of teamwork in evaluating real engineering solutions.
As of personal reflection, I gained a clearer understanding of how quality control supports the development of our portable IoT integrated LiDAR system. I learned that accurate turbidity measurement depends on proper calibration, consistent testing, and careful validation of every component. This project also improved my teamwork and communication skills, especially when coordinating tasks and solving technical issues with my group. Through continuous observation and refinement, I was able to see how total quality management contributes to producing a reliable and effective system.
From looking at the project, I realized how important quality control is when dealing with the real-time data. If the readings are inaccurate, the whole system becomes unreliable. So the use of the cloud dashboards, continuous data tracking, and consistent signal checking show me how the total quality management can support the long-term performance, not just the final output. So working with my groups also helped me understand the quality from another angle, which is team communication. When we compare what each of us observe, we notice different strength and weakness of the innovations, so that the teamwork help us think of improvement, like expanding the system so it's not only for coastal areas, but also for rivers, drains, and other water sources.
From this visit, I learned that total quality tools are very helpful for improving a project. Tools like the fishbone diagram and Pareto chart can show what problem exists and what causes them. Before this, I thought innovation was only about being creative. Now I understand that quality control is also important to make sure a product works well and is safe to use. I also learned a lot from working with my group. Each of us noticed different things, and when we share our ideas, we got a clearer picture of the project. This shows how teamwork and communication are important in quality control.
In conclusion, the visit shows us how innovative and quality go hand in hand. So SIM Pakis One helped me understand how total quality management keep a system accurate, reliable, and also improving. So the experience taught me that good teamwork and good quality practices are what make an innovative truly effective.